Okay, yes. So we're going to talk about online auction, and so um, I have a slice of like a one of the most popular applications of this online auction. It is the um, computational advertising. But I think because limit time, we're not going to go to that specific example. But I have a slide in the Moodle, then you can have a look. So um, this auction, in fact, happening in eBay, for example, where you building this sort of marketplace for people to sort of do transactions. So instead of say give the fixed price, in most of these items that auction in eBay, it not really sure the market price, right? The market price, and because of that, they can actually using the sort of a auction to clear the market. So this is eBay is sort of revolutionized in the very beginning, is because it provides sort of marketplace and in an automatic way. And also, most importantly, through this auction, because auction is that automatically discover the price, therefore make everything automatically, and it's almost like a perfect sort of business model. Because of that, you don't really need to do anything further. You just people automatically put the item there, and then can be sold out. So it's more like a very perfect sort of business model. And another example is online advertising. And so the most famous one is the Google, like a sponsored search, that search on the right side. That although most of people would ignore them, right? They don't really see the ads. But once you find something which is some of the commercial intended queries, and in fact, those ads become hugely important. Not only for the user who want to find the commercial content, but also, the advertisers. So I think about this: Facebook and Google, more than I would say in Google case, even more than 75%. Even Facebook, even more than 90%. Their revenues come from online advertising. So it is. It is substantial. In fact, think about this advertising, the driver behind this, behind the whole internet business, the whole internet, and the underlying, the clearing, the mechanism is in fact auction, right? First auction, second price auction, so on and so forth. So it is also the place to do a lot of machine learning, if you like, right? From the advertiser, you could design some sort of bidding algorithms for advertisers to bid some of the so-called display opportunity to display their ads. Whereas, these intermediary like Facebook and Google really try to sort of estimate using intent, try to sort of categorize these display opportunities based on the underlying user and their intent and their commercial relevancy. So all these things are driven by algorithms, and the automation, essential automation elements there is the auction. So I think that's why the auction play a huge important. Once you're building this up, and there's a lot of like an interesting sort of algorithm based driven by machine learning would work. So the auction is what is an auction anyway? So auction is really a process of buying and selling items, like either services or the product. So they don't have a sort of a clear price. It could have like a I don't know, this lowest price, or what they call this floor price. Floor price, so any price you bid had to be higher than floor price. So other than that, then these buyers tend to provide their offering, and this the auctioneer would sort of taking those bids and figure out, which who should I send those items to? And in most cases, they will sell to the highest bidder, right? And it's auctions are popular in the past, not only the online space, like all these bonds, treasury bills, and this some people privatization. Some company they want to move from migrate from this public company to the private company back again, and so on and so forth. Even like art, like get in all this auction house, they do this kind of selling mechanism. So the internet, obviously, marketplace like eBay and sponsor search, etc. So the setting is actually simple. You got single items, and you have some reserve price, floor price, as I mentioned, and each bidder has their own intrinsic value. So this is very important. But obviously, this is sort of an assumption as well. Is that everybody have their own evaluation. This is not necessary to be reviewed to everybody else, right? Anybody else. It's something that they have. So you can consider this as a type. If you consider that it's a game incomplete formation. So the value basically is willing to purchase up to that price, and the values are independent. So it could be the case that they have a correlated sort of intrinsic value, and then you could, based on that, to do some inference. But a simple model, most simplest model, we consider that they are, independent. So we don't really know the value. So this is already different from the assumption we had, like about this knowledge of payoff in the most of the game that we encountered, apart from the big Bayesian game. How should we proceed this? So first step, we would ask how much people are willing. So suppose you have an item, right? You wanna sort of sell this. The auction would solve the following important question: is that so if you got this intrinsic value for each of these potential buyers, what if they lie, right? They're not necessarily to say their intrinsic value. They could say something lower than that, right? And what's going to happen if they can able to manipulate the outcomes? If they try to lie or have some bit really to serve their alternative purpose, they're not necessarily to give you true value, but try to give something else in order to get a benefit from it. So the question for us is how can we design a mechanism in order to motivate players to reveal their true values or true valuation? So auction theory is really to study that. It's actually a subfield of the field called mechanism design. So think about the mechanism design is more like kind of a inverse problem of this game theory, where we want to sort of the market, the user behave a certain way, and then we design the game, right? We know that we have our preferred user behavior, or policy, but we want to design a game such a way this this user would do that kind of favorite preferred sort of action. So think about this, that we're gonna engineering it to really solve an economic problem. So design auction is really in equilibrium, we will get results. So in other words, is that what we want to do is that we want to understand, given this particular auction, which is a Bayesian game, right, is that in equilibrium, in the stable state, what kind of behavior is user intend to do, okay? And then if this equilibrium is in fact what we want, and then we achieve our goal, right? So because in the equilibrium, basically nobody want to deviate from it, therefore it's generally regarded as one of these sort of stable points you want to achieve. So the goal of this auction is obviously is try to maximize revenue, but sometimes you also want to maximize social welfare. In other words, that given the item to the buyer that wanted the most. For example, if that these buyers, a set of buyers, each of them have their intrinsic value. Intrinsic value is sort of we don't really know them, but we would definitely want these item to the people who value the highest, right? Item to the people who intrinsically thinking that's the most valuable. So all could be the fairness, right? We want to give the item to the pool. So it's really depends on what you actually do. So this is really about focus on this really about this. We want to give the item to the buyer who want it most. But also we could looking at it from the auctioneer perspective, right? So from there they want to maximize revenue to see what can do.